Here is a video on tips and shortcuts. Here we would look into some approximations which would simplify some of the problems. Let's continue here. This is video number 16. Okay. We have split that video in some sections. Its the first section is divisibility by 4 and by 8. Next we'll discuss converting between kilos and pounds. Then we'll look at converting between miles and kilometers, converting between Celsius and Fahrenheit. Then we'll look. Okay. Now let's go look at divisibility by 4. Okay, I know we have discussed that before, and I just want to redo it in this video here. Okay. So what's divisibility? A number is divisible by another number if a remainder is 0. So we are looking for a remainder of 0. Okay. So here's the basic problem setup for the division. We divide a dividend by divisor and we get a quotient and a remainder. So in division we divide a dividend by divisor and the answer is quotient with the remainder at the end. That's from Glover's book. Okay. Let's continue. Do you recall how to compute remainder? We do the repeatedly subtract multiples of the divisor from dividend until a number smaller than divisor remains, and that smaller number is the nominal remainder. We also have used altered remainders usually in a division problem. So this is remainder. Remainder is usually smaller than divisor. At least nominal remainder is smaller than divisor. Okay. So same problem again. Okay, and we have, you can refer to it. We had done that before, and that divisibility by remainders discusses the issues we are talking here. Okay? So clearly, to determine divisibility, we need to determine the remainder and see if it is 0 or divisible by the divisor. Let's continue here. A nominal remainder is 0 or a altered remainder is divisible by 0. Our mantra is short and sweet, one line, mental solution. So we need to make determining that remainder easy. So we have to find our remainder and find out easily and do so without dividing. Let us continue here. Still, we continue with same section here. Okay. In our case, divisor is 4. We first subtract multiples of 100. You know what 100 is? It's 25 times 4. Then multiples of 20, which is equal to 5 times 4. And check to see if the remainder is either divisible by 4, and to be that it has to be either 0, 4, 8, 12 or 16. Let's continue. Okay. Okay. So when we subtract multiple 100, what are we doing? We are finding a remainder of dividing by 100. Okay. When we subtract all the 100 we can, then we have a number left which is less than 100, and that's the remainder of dividing by 100. Okay. Do you recall doing that before? Have we done that before? Okay. We sure have done that in the divisions. When we were doing divisions by nickel method, by transpose and apply, and also by straight division, we were dividing by 100. Okay. Or a base number. Okay. We would have two-step divisions. One was, first step was dividing by base number, and 100 is a base number. Let's continue. Next page here. Okay, let's continue here. So example will do that to find trying to see where we did the division by 100 before. Here's an example. Nickel method 75392 by 97. Note that 97 is equal to 100 minus 3. Okay. So and first, and the 100 is 100 times 1. So nickel method division, and that is described in this video here. And we set a problem like that, 75392, and The efficiency is 3, divisor is 1. It's right here. For dividing by 100, we draw a line to the left of 2 digits. Okay? And we call that, if we were to divide by 100, this is the remainder and this is the quotient. And also when we are decimalizing, when we divide by 100, this is where decimal would go. We draw this line to say that this is the remainder section and this is the quotient section. Okay, let's continue. So to divide by 100, we draw a line to the left of 2 digits and the digits on the right are the remainder. Let's continue. Okay. Now how do you find remainder from division by 100? So this is we draw a line and then digits on the right are the remainder. We draw a line to the left of rightmost 2 digits. The 2 digits on the right are the desired remainder, which would be less than 100. How would you find remainder from division by 20? Okay, how would you do that? First, 100 was a base number, so straightforward. We draw a line to the left of 2 digits. There are 2 zeros in 100. So okay. So now how about 20, where we have to find the remainder of division by 20. Same two-step method we have used all the time. We use same two-step method we have been using all the times. So first divide by 2 and then by 2. First by 10 and then by 2. Okay. So okay. So for take example, this is what we had so far. Here's my example. 4, 5, 1, 4, 3, 6. Is that divisible by 4? First is division by 100. We draw a line. We got 36 on the right and 4, 5, 1, 4 to the left. And this is the remainder. This is the quotient. This is the line that says we can divide. Okay. So, and we are looking for remainder only. We'll keep the remainder 36. Okay? The next step, determine the remainder from, now we 36 remainder, we would subject that to successive division. Next division is by 20. Okay? So how we said that we would do that by same two-step method. Okay, let's continue here. So 20 is 2 times 10. First by divide by 10 and then by 2. Okay? So same thing here. So we're going to, we just did divide by 10. 6 is the initial remainder here, and 3 is the quotient when we divide by 10. Now we would divide by 2 again. When you divide 3 by 2, remainder is 1, and the final remainder is 16. 1 remainder from 3 divided by 2, and which is to the left of the 6. 1 and a 6 make it 16. 16 is the remainder when we divide by 36 by 20. So 3 divided by 2 is 1 and remainder is 1. Thus remainder is 36 divided by 20, remainder is 16. And 16 is in this, first 16 is divisible by 4, so is 4, 5, 1, 4, 3, 6. 16 is also in this list of divisible numbers, 0, 4, 8, 12, 16. This is the multiplication table for 4. These are numbers in, this one is in 4 times 1, 4 times 2, 4 times 3, and 4 times 4. And this 0 here is 4 times 0. And remainder of 0 is, means it's divisible, and so is, this remainder is also says number divisible by 4. So 4, 5, 1, 4, 3, 6 is divisible by 4. Let's continue. Okay, now another example is 986,524 divisible by 4. So we went to lots of work to find out it was number was divisible. Now we would go use all the shortcuts we can. Okay? So first is remainder, we split number like that, 986,524. Okay, then draw a line. Okay, and then we cross this thing we don't need. This is a quotient we don't need. We cross that out, toss that out, and 24 is the remainder. Okay, next step, we're going to divide by 20. Okay, and 24 is what we're looking for. So we say we first divide by 10. So we get in 4 is the remainder we know, and 2 is on the left. Okay, then let's take out all the 2's from here. So 0 left. So 4 is the final remainder here. So 4 is in this list of 0, 4, 8, 12, 16. 4 is divisible by 4. So 9, 8, 6, 5, 2, 4 is divisible by 4. What we did? First we took the rightmost two digits and tossed out the ones on the left. That was a quotient and this is the remainder. This line lets me divide a number by 100. Then 24 left. We two-step method again. We divide by 10 here. Draw this line. And then take out all the 2's we can from the left. So there is 0 left here. Final remainder is 4 and a 0 to the left. That's 4. So 4 is divisible by 4 and also is in this list here. So 9, 8, 6, 5, 2, 4 is divisible by 4. Let's continue. Example is 5, 6, 6, 8, 4, 6 divisible by 4. Let's continue here. First we find our remainder from division by 100. Okay, so 46 is remainder. 5, 6, 6, 8 is a quotient. And we'll toss out the quotient. 46 left. We'll subject this 46 to further division by 20. Remainder from 46 divided by 20 is we write down 4 and 6, and then we first is we divide by 10, then 6 is the initial remainder, and we might get some more remainder from left. Then 4 is on the left. Okay, we divide 4 by 2, and first nothing left. Okay, if you divide 4 by 2, that left is 0. Okay, so we get then 6 left, and remainder of 6 is not in. So final remainder is 6 here. 6 is not in this list of 6 is not divisible by 4, and neither is 6 is not in this list either. So this number 5, 6, 6, 8, 4, 6 is not divisible by 4. Let's continue here. Okay, 5, 6, 6, 8, 4, 6 is not divisible by 4. Let's continue. Now try to extend that to divisibility by 8. Okay. For divisibility by 8, we have to quickly determine the remainder of division by 8. Okay, so for that, what we do is, for that, the steps are: find the remainder from division by 1000. Okay, 1000 is 8 times 125. Then divide the remainder further by 200. 200 we got from 1000 divided by 5, and 2000 is 8 times 25. Okay. Then divide further by 40, the remainder further by 40, which is equal to 200 times 5, and 40 is 5 times 8. Okay. Check to see if the remainder is in this list of from the multiplication table: 0, 8, 16, 24, 32. If the remainder is in this set, then the given number is divisible by 8. Let's quick example. Is this number 1, 2, 3, 5, 5, 8, 4 divisible by 8? First we divide by 1000, draw a line to the left of 3 digits, and first divide by 1000. Okay, and so that would mean draw a line here to 3 digits, toss out the left part, which is quotient, and 584 is the remainder. Remainder is 584. Now we divide 584 by 200. What's the remainder is? First 100 1 divided by 100, 84 is the remainder, and then we divide the 5 by 2. Remainder is 1. That's right here. So remainder is 184. Or we subtract our 200 and 200 twice from 584. I got 184 left. Okay, next we'll divide by this remainder by 80. So if we take out 44 times, you got 24 left. So I first divide by 10. 4 is the rightmost digit of remainder, and divide 18 by 4. Another 2 ways remainder here, 24. Okay, 24 is in this list. 24 is divisible by 8 and also is in this list: 0, 8, 16, 24, 32. So this number is divisible by 8. Let's continue. So this number is divisible by 8. Okay. Similarly, we can determine successive divisors for divisibility by 16, 32, and 64. Let us do some exercises. Are these numbers divisible by 4 and 8? R by 8. So first number is 750, 747. This is odd. And theta, you would say it's not even in the code. So we could just say toss it out. Oh, it's not divisible. Now look at other number 89162 82136 657 986038 and some more. Let's continue with next section here. Next section is about converting between kilos and pounds. Let's convert from kilos to pounds. Okay. Conversion is given by 1 kilogram is equal to 2.2 pounds. That's what we are going to use. 1 kilogram is equal to 2.2 pounds. Okay. And we are trying to avoid multiplying by 2.2. Let's continue here. So 2.2 is 2 plus 0.2 pounds, okay, is equal to, so n kilogram must be equal to 2 plus 0.2 times n pounds. Okay, let's continue here, and that's equal to 2 times 1 plus 0.1 times n pounds. Okay, so this is the workout that we're going to do. We would do this. Instead of doing 1 kilogram is equal to 2.2 pounds, we would try to implement it 2 times 1.1. Okay, let's continue here. So first step is multiply by 2. Okay. Second step is add tenth of multiplication, this first step. Whatsoever we get from first step, we'll add tenth of that. Okay, continue here, and that get me the desired pounds. Okay, let's go to example. 32 kilogram is 2 pounds. Multiply 2 by 2 was 2 times 32, which is 64. We started with 32, now we have a 64. Okay? Now we're going to add tenth. Tenth of what? Tenth of the 64, not of 32. Tenth of a 64. So 64 plus 6.4. How do you get tenth? By moving a decimal place to the left by one place. Okay? Okay, this is like divided by 10 is drawing a line to the left of one digit, and that's where decimal goes. 6.4. 64 plus 6.4 is 70.4. 10 is a base number, and division is just moving the decimal place to the left. 64 plus 6.4 is 70.4. So 32 kilograms is equal to 70.4 pounds. Okay, that means 32 kilogram is 70.4 pounds. Let us continue. Now let's go backward, converting from pounds to kilos. Now we'll use an approximation. We'll use the reversal method here. First, last time we did add a tenth. Okay, okay, and to reverse, we have to subtract a 11th. We added tenth to of 2 times n, that is n by 5, which would be 2.2 times n divided by 11. So we have to get a real reversal, to revert the results, we have to subtract 11th. Okay, but we will do approximation here. Step 1, we need to subtract 1/11th of the pounds. Step 2, we would divide that by 2. Okay, let's continue here, but we don't want to divide by 11. Okay, you can divide by 11, which is not that bad, and use transpose and apply method of division. We can had that discussed that division by 11 in this video here. Okay? Continue here. Let's continue. Okay, now division by 11 straightforward using transpose and apply method division. In this section of shortcuts, we are using division by base numbers like 10, 100, and 1000, etc., etc. Let's continue here. Note 1 over 11 is equal to 0 0.09090909. So 0.09 is a recurring number for 1 and 11. Okay, and also that's equal to 1 and negative 1, 1 and negative 1, 1 and negative 1, and 1 negative 1, because 0.9 is equal to 10 minus 1. Okay. Let's continue here. So that is equal to sum of terms like minus 1 to the power I times 1 over 10 to the power I plus 1 for I equal to 0, 1, 2, 3. Okay, so this thing can be represented as a sum of the terms like this. Okay. Let's continue here. For a crude, usually good approximation, we subtract a tenth, okay, which is the first here. We just say, okay, we're going to truncate this series here up at this place here. We won't do any further, so that give me we can get an approximation by using subtracting a tenth instead of 11th. For better approximation, then we go do add another term here, add it 100. So we truncate the series here by adding 100. Okay, okay. And we for further better approximation, we can subtract 1,000 and add a 10,000. But let's see. So first approximation usually good is we subtract a tenth. So that means we truncate the series right here. For still better approximation, we subtract a 1,000 here. That means we're going to truncate the series here. Let's consider example of converting from pounds to kilos. Okay. So let's do the same example here. Let's convert back 70.4 pounds to kilos. Okay. Reversal method for exact calculation, we'll subtract 11th of 70.4, and 11th of 70.4 is 6.4. You can divide by 11. 11 times 6 is 66, and then 4 is the remainder here, dot here, and with 4 remainder from here, and next digit 4 become 44, and 11 44 divided by 11 is 4, so 6.4. Okay? So we'll subtract 6.4. 70.4 minus 6.4 is 64. Okay? Next step is divided by 2. We just the reversal method. Okay, first we subtract, then we divide. 64 divided by 2 is 32. So we got back to 32 kilograms of the previous example. Let's continue here. However, in this section of shortcuts, we are trying to get a quick and dirty approximation. Quick and usually good approximation. We also wish to avoid dividing by 11. So division by 11 is not that bad, but we still want to. It's a Vedic math, short, and also shortcuts. So an approximation. So we are trying to avoid dividing by. So let's do the approximation now. Convert 70.4 pounds to kilos. Let's continue here. Step 1. Subtract a tenth. That means 70.4 minus 7.04. Tenth of that 70. Is 63.36. Okay. Let's get it. Then add a hundredth. Hundredth of what? Of this thing here. Of 70.4. 63.36 plus 0.704 is 64.06. Okay. For better approximation, subtract 1,000. So 64.064, thousandth of that one. That's 0.0704, 63.9936. Okay. Now, so we have 3 approximations here. Okay. One is divided. Basically, the series was 0.1 positive, then 1 negative, 1 positive, 1 negative, 1 positive, 1 negative, and so on. So we have to truncate the series here. For first approximation, we just the first one decimal position after the decimals, and here we have used 2 positions after decimal. Here we have used 3 positions of after the decimal. So we are going to divide by 2. First we divide this one by 2, and then that one by 2, and that one by 2. Okay, let's continue here. So 63.36, this approximation here by is 31.68, and it's minus 0.32. Deviation is minus 0.32. It's less than the result of 32 kilos we got before. Okay, so this is 64.064. From using that one approximation divided by 2 is 32.032. This deviation is 0.032. Okay, so this is a, here we were undershooting the results, here we are overshooting. Okay, our next approximation, if we use next one here, 63.9936 divided by 2, we get 31.9968. So deviation here is negative here. If this one is, we are undershooting it, and it is deviation is minus 0.0032. Okay, let's continue. So every place we go in one step further of approximations, we are getting closer and closer, but we are bouncing back and forth of the actual value of 32 kilograms. Let's continue here. Successive approximation gets us closer to the actual answer. Okay, let's continue. Okay, let's take some example here. Pounds and kilo conversion examples here. Convert 50 kilos to pounds. Okay. First is multiply by 2, step 1, which is 50 times 2 is 100. Second step is to add a tenth of 100. Add of tenth of this number I got in first step. 100 plus 100 divided by 10, which is equal to 110 pounds. So 50 kilos we converted by 2 pounds is 110 pounds. Let's reverse that. So convert 110 pounds to kilos. Okay. Step 1 is subtracted tenth. That's my first approximation. I get a result of 99. If I subtracted 11th, then I would have gotten a, so would have subtracted 11th, then I would have gotten a better answer here. Okay. Then I would, okay, so I'm subtracting 10th, 99 now. Okay. Okay, 99 divided by 2 is 49.5, so 49.5 kilos. Okay, we started 50 kilos in approximation and lost some, and I got it 14.5 kilos. So I am undershooting. Okay, let's continue here. Next example, 33 kilos, 2 pounds. First step, multiply by 2. 33 times 2 is 66. Next step, add a tenth of this thing. Add a tenth of this thing here. So 66 plus 66 divided by 10 is 72.6 pounds. Continue here. Let's revert that. Convert 72.6 pounds to kilos. First is subtract a tenth, which is my first approximation here, 65.34. Okay. So next step is divided by 2, 65.34 divided by 2. Okay. Next is which equal to 32.67 kilos. So this is we started with 33 and lost a 0.33 kilos in approximations. Okay. So deviation is, we are undershooting here, and deviation is minus 0.33. Okay. Here deviation was minus 0.5. It was still undershooting. Okay. Let's continue here. Another example. Convert 72 kilos to pounds. 72 multiplied by 2, getting 144. Add a tenth, 144 plus a tenth of that, tenth of this, 14.4 is 158.4 pounds. 72 kilos and 158.4 pounds. Okay. Let's continue here. Convert that back, 158.4 pounds to kilos. Okay. First approximation is subtract a tenth, 158.4 minus 15.84. Okay. That gets me 142.56. Okay, okay, 142.56. Okay, let's continue here. Next step is divided by 2. I got 71.28. So I'm undershooting again. Instead of 72 kilos, I got 71.28. My deviation is minus 0.72. Let's continue next section here. In this section, we'll discuss converting between miles and kilometers. Okay. So cool math tricks to convert between miles and kilometer. Okay, I got that from internet. Okay, let's continue. So desired conversion is 1 mile is equal to 1.609344 kilometers. Okay, or 1 kilometer is equal to 0.621371119. Okay, let's continue here. There is a write-up online about using Fibonacci series for approximate answers. Okay, and here's the link. Okay, let's continue. The series is 1, 1, 2, 3, 5, 8, 13, 21, 34, 5, 55, 89, 144, 233, 377, 610, 987, 1597, and so on. Continue. A number in a series is obtained by some adding the two previous numbers. We start with two ones, and 1 plus 1 is 2. You can start with 0, comma 1, 0 and 1 sequence numbers from first number start with 0 and then 1, then add them together to get 1, then add two ones together to get 2, add 2 and 1 together 3. So similarly add 55 and 89 to get 144, okay, and so on. Okay, and you can continue forever. Okay, let's continue here. Ultimately, the series growth rate is, there is, if you look at growth rate, 13 to 8 divided by 8 is about 1.6. Okay, okay, and so ultimate growth rate when you go it into hundredth and 200th term is the ratio is given by 1 plus the square root of 2, which is also called a golden ratio, or divided by 2 here. Okay, and phi, which is phi, and which its value is 1.618033, and so on. Okay, long value. Okay, and that's called a golden ratio also. Continue. First, we look at cool matrix to convert between miles and kilometers. Okay, so we start with series here 1, 1, 2, 3, 5. This is 500 series, and which continues after 1597. Okay, so it doesn't end here. Let's continue. Series 8 miles equal to, from 8 miles equal 13 kilometers. So for converting between miles to kilometers, you take the next number in the series. Exact value would have been 12.87452 kilometers. So this is an overshoot. Okay, and so similarly 13 miles is equal to 8 kilometers. 13 kilometers is equal to 8 miles backward. 8 miles is equal to 13 kilometers, and 13 kilometers is equal to 8 miles. Let's see, if a number like 100 is not in series, what do? We split the number in its some other numbers which add them up. 89 plus 8 plus 3 is 100, so we'll use those numbers. 89 is here, 8 is here, and 3 is here. So to convert 100 miles to a kilometers, so we take 89 here, and 1 to the right is 144. We use 144. Next, number 8. 8 is here, 1 to the right is 13. We use 13 here. Next is 3. 3 is here, number to the right is 5. So we use a 5 here. We have 144 plus 13 plus 5 is 162. So 100 miles is equal to 162 kilometers. If we had to get 100 kilometers, we have to convert to miles. So 89 is here, so we'll take 1 to the left, 55. 55 is here. Okay. Next is 8. 8 is here in series, and 1 to the left is 5, so we use 5 here. Next is 3. 3 is here in series, and 1 to the left is 2, so we add 2 here. 55 plus 5 plus 2 is 62 miles. So we convert 100 kilometers to 62 miles. 100 miles to 162 kilometers. Let's continue. In this section, we'll use some approximate conversion instead of using the Fibonacci series, which was also approximates. Okay? So 1 mile, we'll use this conversion. 1 mile is equal to 1.6 kilometers. So first we'll do add a half, then add a tenth of the original number. Okay? Convert 12 miles to kilometers. Okay? First add a half. 12 plus 6 is 18. Then add 1/10 of what? Of the 12. 18 plus 1.2. We're adding 1/10 of 12, not of 18. Okay? So we add 1/10 of the original. 18 plus 1.2 is 19.2. So we converted 12 miles to 19.2 kilometers. Let's continue here. So 12 miles is equal to approximately 19.2 kilometers. Okay, let's do convert backward here, kilometers to miles. For this section, we'll use an approximate conversion. Okay, and exact conversion is 1 kilometer divided by 0.62137119 mile. Okay, and what we are trying to do is, in converting from miles to kilometer, we use a 1.6. Now we would use a 1 over 1.6, which is 0.625 as a factor. But instead of multiplying by 0.625, we will do using doubling and halving and adding. First thing we have to take a half, then add a fourth of above or eighth of the original number. Add fourth of this number we got after half. Okay, okay, and that's it, we already got. So let's go example. Convert back 19.2 kilometers to miles. Okay, first we take a half. 19 divided times 2 divided by 2 is 9.6. Okay, we took a half. Now we're going to add a fourth of this number here. Second step is add one fourth of this number, not of that number. One fourth of this number. One fourth 9.6 is 2.4. 9.6 plus 2.4 is 12. So when we convert 12 miles, we got 19.2 kilometers. When we convert back 19.2 kilometers, we got 12 miles, and we did not use a reversal here. Okay? So 19.2 kilometers is equal to 12 miles approximately. Let's consider some examples. Okay, on left side we'll do convert from miles to kilometer. On the right side we'll convert them back to miles. So convert 30 miles. Add half. 30 plus 15 is 45. Okay. Then add a tenth. We'll do 45 plus tenth of 30. 48 kilometers. Okay. Then convert to 48 kilometers back. Take a half. 48 divided by 2 is 24. Then add a 4. 25. 4 plus fourth of that 6 is 30 miles. Okay. Convert 50 miles. 50 miles. Add half. 25. 50 plus 25 is 75. Then add a tenth of the original. 75 plus 5 is 80 kilometers. 50 miles is equal to 80 kilometers. Okay, let's convert them back. Convert 80 kilometers. Take a half. 40. Add a fourth of that number. 40 plus 10 is 50. Let's convert 60 miles. 60 plus 30. Add half. 90. Add a tenth of 60. Okay, 96 here. Okay. Convert to 96 kilometers. Take a half. 96 divided by 2 is 48. Add a fourth of 48. 48 plus 12 is 60. Start with 60 miles, get 96 kilometers. Start with 96 kilometers, get 60 miles. Okay, let's continue. Let's continue the next section here. Next section is converting between Celsius and Fahrenheit. Okay, let's continue here. It's converting between Celsius and Fahrenheit. Okay, formula is F minus 32, that's degrees in Fahrenheit, minus 32 divided by 9, which is equal to C over 5. That's a degrees in centigrade divided by 5 Celsius. Let's continue here and apply transpose and apply to simplify this thing here. We let's say have some number in terms in numerator and some in denominator. Let's simplify by using a transpose and apply. Okay, basically we're going to multiply both sides by 9. Okay, that means f minus 32 is equal to 9 divided by 5 times c, and 9 divided by 5 is 1.8, okay, times c. And so degree in Fahrenheit minus 32 is equal to 1.8 times degrees in Celsius. Let's continue here. So Fahrenheit is equal to 1.8 times C plus 32. 1.8 times the degrees in Celsius plus 32. Let us continue here. And for Celsius, we will use the approximate reversal method to convert Fahrenheit into Celsius. We would use a reversal method. Let's continue here. Convert 40 degrees Celsius to Fahrenheit. Okay, let's continue. So first we'll do a double of 40 times 2. So we will try and do 1.8 times, but we're going to do double. 40 times 2 is 80. Now we will subtract a tenth from this number here. Tenth of this double, not tenth of the original number. So we're going to take a tenth of this, subtract that, which 80 minus 8 is 72. We just multiply 40 by 1.8 to get 72, and we did through first doubling and subtracting. Okay, and tenth of a number is just moving a decimal place to the left. Let's continue here. Then add 32 from the formula. 72 plus 32 is 104 degrees Fahrenheit. So 40 degrees Celsius is 104 degrees Fahrenheit. Let's continue here. So now let's convert that back into degrees Celsius. So first we do is subtract. The last thing was add 32. So we are going to subtract 32 is equal to 72. We are doing a reversal here. Now we had subtracted a tenth here, and we will add a tenth. This is an approximation here. We should have, for exact number, we should be adding a ninth. So instead we are going to add a tenth, which is 72 plus 7.2 is 79.9. If I had added ninth here, 72 plus 8 would be 80, will be exactly where we are right here. Okay? But here is approximation here. We are going to add a tenth. Okay? Then add another hundredth. That would get me a better approximation. So we're getting closer here. So 79.2 plus 0.72, which hundredth of that is 79.92. Okay, then we could continue adding some more terms here, which would get me a closer and closer. Now we are going to divide. 79.92 divided by 2 is 39.2 degrees Celsius, and approximately it's not 40 we started with, but it's off. It's 39.92, and it's less than 40, so deviation is minus 0.08. This is degrees Celsius. Let's continue here. So convert minus 40 degrees. Let's do another example here. Convert minus 40 degrees Celsius to Fahrenheit. Double is minus 40 times 2 is minus 80. Okay. Then we subtract a tenth. Tenth of minus 80 is minus 8. So we subtract minus 8. That gets minus 80 plus 8 is minus 72. So now we add 32. Okay. Minus 72 plus 32 is minus 40 degrees Fahrenheit. So minus 40 degrees Celsius is minus 40 degrees Fahrenheit. Let's continue. Okay, let's go continue with next section here. Next section is converting between reckoning numbers for 1 over 7. Okay, let's continue here. Reckoning numbers for 1 over 7. Okay. Let's try dividing 1 divided by 7. Okay. If you do that, is that hard? It's not really that hard. You just divide by a single digit, okay, and we just keep adding zeros to the after decimal place. It's straightforward. Okay, and what's the quotient? Did you get that number? 0.142857, and continuing the same numbers. Okay. Did you notice anything special about this division here? What's the quotient digit after last 7? How about more digits? If you continue there, you continue to get 142,857, 142,857, and so on. You see the quotient digits keep repeating. The 6 digits in quotient keep repeating. Okay? And they should do repeat. Such repeating numbers are called recurring numbers. So recurring numbers are numbers they are repeating. Okay, let's continue here. How do you find recurring numbers? There are two ways. Okay, the first, at least there are two ways I know of. Okay, let's continue is first division, direct and indirect. We just did direct division here. We had done indirect division in the division methods, which was Nicola method. We did a 1 over 13 using its equivalent 3 divided by 39, and we did the same thing again in a transpose and apply method where we use 7 over 91 as equivalent of 1 over 13. Okay, so that's indirect method. This is direct we just did here. Okay, another is by construction. So we're going to use a construction method here to compute the same number, recurring number as we have here. Okay, let's continue. Let's go and construct that. And observation, number of recurring digits is 6, which is an even number. 6 is an even number, and number of recurring digits are 6, which is 142857. Okay, let's continue here. A recurring number fraction has an equivalent common fraction form, okay, of the type, okay, which is 6-digit recurring number have a common fraction of this type. 6 digits in the numerator and 6 nines in the denominator. 6 digits in numerator and 6 nines in the denominator. Okay, now how do you get a nines, 6 nines by multiplying? Okay, we are going to use convert 1 over 7 to this form using multiplications. Okay, how do you get 9, 6 9 by multiplying? Okay, any ideas? Let me give you the ideas I know. First of all, you can get 6 is an even number, and you can get that two ways. One is 1001 times 999. 999 is 3 digits, and this is a 4 digits with the 2 zeros in here and 2 ones in the end. And also you can start with 6 ones and multiply by 9. Okay. Okay, so you can get 6 nines using these, and you can use the prime factors of these things and say uh, make your life a little harder, so make it harder, but these are simplest way you can get. This, okay, let's say this is last multiplication you need to do to get a 6 nines. Either you multiply these numbers together or this number together. Okay, let's continue here. If 1 over 7 has the above form like this, 7 must be a factor of both 1001 and 111111. Please you go ahead and verify. Okay, it is okay a factor. So, and in fact 1001 is 143 times 7, and also 111111 is 111 times 143 times 7. How do you get 143? One way is that I need a 1001 here. So I divide 1001 by 7. Another way to do is there's a subsutra which associates 143 and 7 through multiplication. So here's multiplication here, here's 143 and 7, and they both come out to 1001, and I would need that to compute a sequence of 6 digits, 6 nines. Okay, let's continue here. So you know that we are trying to convert equivalent form of 1 over 7 in this form here. 6 digits in the numerator and 6 nines in the denominator, and that would give me a recurring number of 6 digits long. Okay, let's continue with construction of 1 over 7. Now we can construct a recurring number for 1 over 7. We have already developed all the products we need to multiply and divide by. Let's continue here. We start with 1 over 7, okay, which is equal to 1 over 7. Okay, no problem there. Straightforward. Okay, is exactly equal to. Then we are going to multiply and divide by 143. That was our first multiplier. Okay. We did multiply and divide by 143. Okay, let's see. Then after that, we want to multiply, get all 9s in the denominator. So we multiply and divide by 9, 9, 9. Okay, let's continue here. Let's continue. Okay, then from here, denominator is 7 times 143 times 999 is all 9, 6 nines, 999, 999. That's what we know from the workout in the previous slide. And numerator is 1 times 143 times 999. And which 143 times 999 is 142857. We are multiplying by sequence of 9, and we have done that before, and it, okay, that's is equal to 142857 divided by 999. 999,999. Okay, okay, and for this multiplication, you can refer to multiplication by sequence of 9s in this video here. Okay, let's continue here. So 1 over 7 is again is equal to 0.142857, the recurring. If a denominator was 1 million instead of 999,999, it would be exact fraction 0.142857, because division by a base number is just moving decimal place to the left. Okay? But this is a 1 less than the base number, so in that case this becomes a recurring fraction. 1 over 7 is 0.142857 recurring. Okay, now let's look at some properties of the 1 over 7. Okay, which is the first thing we're going to take a look at cyclic property. Observation: you can take 6 digits starting at any position of 142857, and you get a recurring number of the for n over 7, where n is in 1 divided by 6. Let's continue here. Let's first try to construct a recurring number for 2 divided by 7. Okay? So numerator is 2 times 143 times 999, which is 286 times 9999, and which you know using the video previously discussed methods of multiplying by sequence of 9. You get it 285714. On the left, it's 1 less than this number. On the right, it is all from 9 and last from 10 of 286. Okay, so 714. Let's continue here. Do you see that to be 6 consecutive number? So these are 285714. Okay, these are the same number digits we have. We had 1, 4, 2, 8, 5, 7. Okay, before in 1 over 7. For 2 over 7, we got 2, 8, 5, 7, 1, 4. We start at 2. We got 2, 8, 5, 7, 1, 4. We got 2 divided by 7. Let's continue here. So this is what we got. If you say put together two sequences here, 1, 4, 2, 8, 5, 7, followed by 1, 4, 2, 8, 5, 7. We start at 2, take 6 digits, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1, 4. We got 2 divided by 7. Okay, let's continue here. If we start at 4, which is next second digit here, we got 0.42, 0.42857, and 1. That's the recurring number for 3 over 7. Okay. You start next digit here, which is 2, 285714 is a recurring number for 2 divided by 7. Okay. Okay, now we do a next digit here, 8, start at 8 here, 857142 is a recurring number for 6 over 7. Start at 5, 0.571428 is a recurring number for 4 over 7. Okay, start at the 7, right here 7. We got 0.714285, which is recurring number for 5 over 7. So we got 1 over 7 was this number here, 2 over 7 is that number here, 3 over 7 is this number here, 4 over 7 is that number, 5 over 7 is that number, and 6 over 7 is that number. Okay, let's continue. Okay, let's see where you can use the cyclic numbers. Okay, these so what? Okay, in some situation these can make you look like a genius. Okay, let's continue. Determine 23 by 7 to 6 places after decimal. For that, you know, that is a snap. For you, that's a snap. And it's a 3. First of all, it's 7. It's a 3 in a whole number, and 2 divided by 7 is a fraction, which is, so you start at 2, 2.285714 recurring. Okay, so that, okay. What's 155 divided by 7? 155 has a 22 whole numbers and 1 over 7 as a fraction, so which is 22.142857. And how about 39 by 7? That's it. 5 as a whole number, 4 as a fraction, so that's it is 5.571428 recurrent. References, you know that there's the reference of first reference is uh, this Vedic Maths ebook.com, memory mentor underscore maths underscore tips dot pdf. I got most of the ideas from this ebook, but I used my own approach. Okay, my approaches are different. This ebook has numerous other tips and shortcuts. Okay, so it has a multiply by 11, multiply by 12, square of numbers ending in 5, and some other yeah, working with the times also. Okay, let's continue here. Next is a teacher's manual, Vedic Math teacher's manual, elementary level by Ken Williams, and this book is available from vedicmaths.org site. And if you look at PDF form, that is free. Then look up uh, primary reference for anything Vedic math is Bharati Krishna Tirthaji's book, Vedic Mathematics. An authoritative book is Discover Vedic Math by Kenny Williams. It's the most complete book, authoritative and consistent notation. The book organizes the material by sutras. Okay? And then Glover's book, 3 books. They are very easy to read and are not as complete as the either of the first 2 books are, but it's easier to read and cover most of the topics. Okay, and yeah, then it has plenty of geometry which I have avoided. Okay, let's continue.